So hello everybody and welcome back to a brand new video, and in this video I'll cover problem C, that was robot in a hallway from education round 133. Also this problem was quite hard than a usual div2 C, so if you guys have some doubts, be free to leave them in my Discord server or in the comments as usual. So let's start with the problem. So in the problem we have been given a grid that has two rows and some m columns, right? So we have something like this, and we started the cell 1 comma 1, we started cell 1 comma 1, and we can make 5 type of moves. Either we can make a up move, we can make a down move, we can make a left move or a right move, or we can stay at the same cell, right? So we can make 5 type of moves. So we have been given a grid, we started 1 comma 1, and we want to traverse the whole grid such that we want to traverse the whole grid or find a path in the whole grid such that every cell is visited exactly once. Every cell is visited exactly once. So that's one part of the problem. Also, along with the cells, we have been given some times, right? Every cell has some time. So something like this. Let's say we have 10 here, 5 here, 3, 2, 4, 1, something like this. So what that means is that a cell ij, a cell ij is logged until time, is logged until aij, right? So you can only visit a cell after it has been unlocked. So you can only visit a cell, when your current time is greater than aij. For example, for the following cell, your time is equal to 5, that is it will remain logged until 5 seconds. So you can only visit this cell after your current time is more than or equal to 6 seconds. So you can say you can only visit a cell when your current time is greater than aij, or you can rephrase this and you can say you can only visit a cell when your current time is greater than or equal to aij plus 1, right? That is the same thing. So if your time is aij, you can only visit a cell after or equal to time aij plus 1. So we want to create a path that will visit every cell exactly once, and the time required is minimum, right? So that is the problem. Given a 2D grid with some cells that are logged for some time, you have to find a path that visits every cell exactly once, and the time required for that is minimum, right? So first of all, we will try to find what kind of a path we will have, right? So first of all, we will try to find a pattern for the path. So in step 1, we will try to find a pattern for the path that visits every cell exactly once, and then we will try to minimize the time, So if you will try to draw out some paths, you can see a pattern, right? So if you try to draw out some paths, you will observe a pattern. The pattern is that your first part of the path will have a zigzag structure. So something like this, right? So your prefix of a path will have a zigzag structure. And your rest of the path, that is your suffix, will have a cyclic structure, something like this, right? So you can say it kind of forms a clockwise cycle, right? It kind of forms a clockwise cycle, right? So that is how your path will always look like. Why so? Because if you try to draw out some path that does not follow the following pattern, for example, something like this, let's say you have a zigzag first, and you try to draw a cycle, then you again try to do zigzag. So something like this. As you can see here, you are missing a cell here, right? So if you try to disobey the pattern, you will always miss out some cell, right? So if you try to, after doing some zigzag, if you again try to do some zigzag, you will always miss a cell, right? So that's why the following pattern is always satisfied. So you will always have a zigzag in the first part in the prefix, and then you will have a cycle clockwise or anti-clockwise in the suffix part. So that is your path. So now you know how your path will look like. So now you want to minimize its time, right? Obviously, as you can see here, let's call this thing a breakpoint. Let's call this thing a breakpoint. So there can be n breakpoints, right? There can be n breakpoints in the grid. There can be O of n breakpoints. And to find the time for every path, it will take you more O of n time, right? This is for iterating over breakpoints, and this is for finding time. So if you try to do brute force and try to find the time for every path, it will take you O of n into n. That is, it will take you O of n square time. Obviously, that is not optimal, right? It is not optimal. So now you have to somehow find the time for every path in O of 1 time, right? So you can iterate over all breakpoints, and for finding time, you don't want to make this O of n factor. You want to make this O of n into O of 1. If you can somehow make this O of n into O of 1, then you can iterate over all breakpoints, and your answer will be easily O of n, right? So now you have to somehow make this finding time thing into O of n to O of 1. So how can we do this? Obviously, if you are familiar with prefix and suffix arrays, as you can see here, your path is a prefix and then a suffix. So if you can somehow do some pre-computations for the suffix part, then you can easily solve this problem. So to make this from O of n to O of 1, let me remove this one. So to make O of n to O of 1, we have to pre-compute the suffix. How can we do that? Let's see. Let's say you are at your last cell, right? So obviously you are here. This is your cell 1, n, and this is your cell 2, n. So there are two possibilities, right? Either there can be a clockwise cycle here, so something like this, or there can be an anti-clockwise cycle here, so something like this, right? So I will only talk about clockwise cycle, but the same argument goes for anti-clockwise, right? Because of symmetry. So I will only talk about clockwise cycle. So when there is a clockwise cycle, we'll try to we'll keep a suffix vector clock, right? That will tell you the worst time. That will tell you the worst time, clock of I, worst time to complete if you start your cycle at column I, right? Or you can say clockwise cycle here. You can say clockwise cycle, right? So I will try to make a suffix array clock of I that will give me the worst time to complete if we start a cycle at column of I. So first we will try to compute this for the last column, and then we will try to extend it to the other columns, right? Also, I am adding 1 to all my times, right? As you can see here, my current time is greater than or equal to aij plus 1. So I can just add 1 to all my aij's, right? So my let's call this a dash ij, right? So you can say my current time is greater than or equal to a dash ij. So I will follow the following convention going on, right? So now let's try to compute our suffix array, right? So you have a clockwise cycle at the end. You have your 2 times a dash 1 comma m and a dash 2 comma m. So there are two possibilities. That is, either your a dash 1 comma m is logged, right? That is, you have to wait at a dash 1 comma m, or either your a dash 2 comma m is logged and you have to wait at a dash 2 comma m. So there are two cases. You have to wait at a dash 1 comma m. right? So if you have to wait here, then you will reach the following cell at a-1 comma m, and then it will take 1 extra second to reach your cell cell 2 comma m. So your time at the end will be how much? a-1 comma m plus 1, right? Because you have to wait here and then you take 1 extra second to reach your last cell. Similarly, if you have to wait at cell 2 comma m, if you have to wait at a-2 comma m, then the time it will take is how much, right? You have to wait for the last cell, so your time will be a-2 comma m itself. Your time will be a-2 comma 1 itself, right? So obviously we are trying to find the worst time it will take to complete if you start your second column I. So your answer will be how much? So your clockwise of m will be equal to maximum of a-1 comma m plus 1 and a-2 comma m. Now you guys might have a doubt here that why are you saying we have to wait at either a-1 comma m or either at a-2 comma m? Why cannot we wait at both, right? It can be a case that both are logged. So like if both are logged, then it is the same case as when your a-2 comma m is logged, right? Because if you have to wait at a-1 comma m and then you have to wait at a-2 comma m, it is the same case that you have to wait at a-2 comma m, because in the end your time will be a-2 comma 1 2 comma m itself, right? So you always have to think about the last cell that is logged. All the cells that were logged before, we don't care about them, right? So your case when both a-1 comma m is logged and your a-2 comma m is logged, it is contained in the following case itself, right? So you don't need to think about those cases separately, right? So now we have found the answer for your column m. So now you have to find the answer for your column m minus 1. So how can you find the answer for your column m minus 1? So now you have a clockwise cycle that starts as the column m minus 1. We already know the answer for your m column, that is clock of m, right? We already know the answer for this for your mth column. So here we have 2 times as well. We have a-1 comma m minus 1 and we have a-2 comma m minus 1. So again we have to consider all the cases. That is, we have to consider the worst case. So those cases can be that you are stuck at, you wait at a-1 comma m minus 1. So the time it will take is how much? It will take you a-1 comma m minus 1, and then you have to move 3 more cells. So you have to add a 3 here. Your second case is when you have to wait at a-2 comma m minus 1. So your time here will be how much? Your time here will be, because you're ending at a-2 comma m minus 1 itself, so your time will be that itself. So it will be a-2 comma m minus 1 itself. So now you have considered 2 cases when you have to wait in column m minus 1, right? You wait at a-1 comma m minus 1 and at a-2 comma m minus 1. But there might be a case that you have to wait in column m, right? You have to wait in column m. So how can we think about that case, right? We already know the worst time to end at a-2 comma m, right? Because we know clock of m. So we already know the worst time that it will take to end at column end at cell a2 comma m, right? And it will take just 1 extra second. It will take just 1 extra second to move from a2 comma m to a2 comma m minus 1, right? So you can say if you wait anywhere, wait at column m anywhere, it can be either 1 comma m or 2 comma m, we don't care about that. Your time will be how much? It will be clock of m, right? The worst time to reach cell a2 comma m, and then 1 extra second to move from a2 comma m to move to a2 comma m minus 1 and plus 1 here, right? So now your answer for clock of m minus will be how much? It will be maximum of a-1 comma m minus 1 plus 3 a-2 comma m minus 1, and the third term will be clock of m plus 1, right? Similarly, you can extend the same thing to column m minus 2. I will give you 1 more column, right? And then we will move on to the code, right? So if you try to draw the same thing for column m minus 2, we now know the answer for these two columns, right? It is clock of m minus 1. Now you know the worst time to reach your cell 2 comma m minus 1. So now you want to find the answer for column m minus 2. So you have a dash 1 comma m minus 2 and a dash 2 comma m minus 2. So your clock of m minus 2 will be how much? Your clock of m minus 2 will be, if you stuck at the following cell, then it will take you a dash, it will be maximum of a dash 1 comma m minus 2 plus 5 more moves, right? Because you have now 5 extra cells. So plus 5 more moves. If you are stuck at a dash m comma m minus 2, the answer is the time itself. So it is a dash 2 m minus 2. And if you are stuck in anywhere in column m minus 1 or m, your answer will be clock of m and one extra move to move from 2 comma m minus 1 to 2 comma m minus 2. So it will be clock of m minus 1 plus 1. Okay. So following using the same formula, you can find the suffix. You can find your clockwise cycle suffix for every column, and similarly anti-clockwise for every cycle, right? So now the problem is simple enough, right? So now you can just start from your starting cell, right? Start from here. So initially your breakpoint is here. Initially your breakpoint is here. So like your zigzag ends here and your cycle starts from here, right? Cycle starts from here. So your answer here will be how much? Your answer here will be your clockwise cycle, right? Your clockwise cycle starting at column 1, and there might be a case that you are not blocked anywhere. You are not blocked anywhere. So for that case, you have to also consider that case, that is current time plus the number of cells that we are visiting. So we are visiting how much? We are visiting 2m cells here, right? So your answer will be maximum of these, right? That is clock of 1, right? That is clockwise cycle. That is you start a clockwise cycle at the following cell, and that is your current time plus 2m cells. Why so? For case when you are not blocked anywhere. When you are not blocked anywhere. After, then you can just move your breakpoint to the next column, right? Then your breakpoint will move here, and you have moved these two cells in a zigzag manner, right? So then you can increment your current time, right? Increment your current time appropriately, and then there will be an anti-clockwise cycle. Now for column 2, there will be an anti-clockwise cycle, right? So now you have to consider for that. So now your answer will be how much? Minimum of answer and maximum of anti-clockwise cycle. So you can say anti-clock at column 2 plus how many cells are we visiting here? Not plus here, plus comma current time and the number of cells that we're visiting, that is 2m minus 2. Right. So similarly, you can like keep moving your breakpoint and find the answer for every breakpoint, and your answer will be the minimum answer that you found among all the breakpoints, right? So your answer will be the minimum answer you found along all breakpoints. So if you guys want to see the code for this, let me show you the code. Here's the code. So I have two vectors. Suffix vectors, that is clock and anti-clockwise light, right? And then I have my grid, that is a 2D grid of that has 2 rows and n columns. So I increment my time, right? Like I said here, I compute a new time. So like I can use this greater than equal to operator. I increment time so that I can use this greater than equal to operator, right? So I convert my aij into a dash ij by adding a 1, because I think it was easier for me to work with the equal to, right? So that's why I added 1 to every time. So first of all, for my last column, that is for my last column, if you see here, for my last column, my answer is how much? A dash 1 comma m plus 1 and a dash 2 comma m, right? So that is here, that is v of 0 n minus 1 plus 1 and v of 1 n minus 1, and similarly for anti-clockwise the same thing here. Then for other columns, we have to think about 3 cases, right? That is, you start at the first cell, right? That is you for about, let's say here, that is you start at the first cell, that is you are logged at the first cell, that you are logged at the first cell, you are logged at the last cell, and you are logged somewhere the columns after this, right? Similarly the same thing for anti-clockwise, right here. And then I will start simulating the process, right? So I will start with my current time equal to -1, and if my column is odd, I'm using 0, I'm using 0 indexing. So if my column is odd, that is my column is odd, then I will have an anti-clockwise cycle, right? This is my column 1, this is column 0. So if my column is odd, then I will have an anti-clockwise cycle. And if my column is even, let's say something like this. If my column is even, let's say 0, 1, 2, then I will have a clockwise cycle. So that's why I'm keeping 2 cases. So if my column is odd, then my answer will be how much? It will be current time plus the number of cells that I'm visiting, or the worst time it will take, that is for an anti-clockwise cycle for the following column, that is anti-clockwise of I. Then I will simulate. So now I know the answer. So now I know the answer for the anti-clockwise cycle, right? So now I will move my breakpoint here and I will visit these 2 cells. So to visit these 2, I will check my current time is equal to how much? Maximum of current time plus 1 and v of I comma 1. Because there are 2 cases. When I move from this cell to this cell, there are 2 cases. Either the cell is logged or I am using 1 second. So if the cell is logged, then it will take me how much time? It will take me v of column 1, and it is so v of 1 comma 1. Otherwise it will take me current time. If it is unlogged, it will take me current time plus 1 seconds, right? So these are 2 cases. So when I'm doing the simulation, so there are 2 cases. So if the cell is unlocked, it will take me current time plus 1. Otherwise it will take me v of 1 comma I. Similarly, I have now moved to the following cell, so I also have to move 1 cell upwards. So the following line is helping me move 1 cell upwards. So that is for when my column is odd. So when my column is even, then I have to think about the clockwise cycle. So here my answer is current time plus cells and the clockwise cycle starting at column I. And then I will again do the same thing. I will simulate moving 2 cells, that is I will shift my breakpoint, and in the end I will just print out my answer. That is my final minimum answer over all the breakpoints. So I think the problem was pretty hard. So if you guys have a doubt, feel free to ask in the comments and or on my Discord server, and I'll be more than happy to help you guys out. See you guys in the next video. Also, if you guys don't know, Continue Newton School is offering a full stack development course. The course is over 6 months long, and it is totally based on pay after placement model, and you don't have to pay anything. There is 0 hidden fees, there is 0 upfront fees, and they are granting you a minimum package of rupees 5 lakhs. And the average package is rupees 7 lakhs and the highest package is over rupees 26 lakhs. So it is a very great opportunity. Also, all their mentors are from top MNCs like Google, Flipkart, Zomato, etc. Also, they will get you placed into the top MNCs as well, like Google, Flipkart, Zomato. So you can learn from the mentors that are working at those companies, and you can land a job at those companies yourselves. Also, you don't need to worry if you guys think कि यार मेरे को भी coding आती नहीं है, मैं भी fresher, मेरे को बिल्कुल नहीं आता है. The course is over 6 months long and they will teach you from scratch. So you can still sign up for this. And if you guys are looking for a career in the tech field, this is a very great head start that you should sign up for. And if you want to land a job, I highly vouch for this. And if you guys want to sign up, there will be a link down below and you can go and sign up from there. So yeah, be sure to sign up for this, and I will see you in the next video. Bye bye.